Today's show is sponsored by Megaport. Are you looking for an easier way to connect all your clouds that you're using? With Megaport's Network as a Service platform, you can spin up private connectivity to as many clouds as you want, anywhere in the world in minutes, not months. All the world's top cloud service providers, such as AWS, Azure, Google, are already on the network and at your fingertips. And it's all software defined, no hardware necessary. Just point, click, and connect. So if you're looking for a way to improve network performance and security, lower cloud cost, and turn up hybrid cloud and multi-cloud connections quickly and easily, Megaport is the cloud connectivity solution for you. Learn more at megaport.com. That's megaport.com. Reimagine connectivity.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. As we bust through the November month, we're into November 2021, just 2 months left of the year, and hope everybody is doing well. Hope they're making holiday plans and get a chance to spend some time with some friends and family, and maybe wind down a little bit for the year if you're in Q4. So let's jump right into Cloud News of the Week. It is earnings season. It is Jordan Novett season, as we like to call it around here. Jordan is, if you don't follow him on Twitter, he's the reporter for CNBC that covers all the tech earnings, does an awesome job. I mean, does an awesome job in general of covering tech, but this is sort of our favorite time of the year for the quarter. So let's jump right to those numbers, and then we'll jump into a few kind of interesting acquisitions that happened over the last week or so. AWS announced their numbers as part of Amazon. AWS up 39% to about a $16 billion quarter, so roughly $64 billion run rate now for AWS. Microsoft announced the numbers for Azure and Intelligent Cloud. So Intelligent Cloud inclusive of Azure and LinkedIn and GitHub and a few other things, Windows Server and so forth. Up 31% to around $17 billion. So again, as we always say, the Azure numbers are a little less transparent than the AWS or GCP numbers, but they continue to be growing at a healthy rate on a big number. And then finally, GCP up 45% on about a $5 billion quarter. So GCP continues to grow. All three continue to grow at fairly substantial rates. They seem to be slowing just a little bit, but it'll be very interesting this week, and we'll get to it probably next week. Amazon is, I keep saying that. Microsoft is having their sort of version of reInvent, in which they make all the new Azure announcements, and so we'll get to that next week. We're gonna do a show about the Azure announcements, as we typically do for the AWS announcements, and then obviously in end of November, December, we will get to the reInvent one. So it'll be very interesting to sort of watch. As Azure continues to grow and expands where they are, we continue to see GCP grow, although still at a much smaller footprint than the other two. And then I was always everybody's favorite event, watching the 3-hour keynote of AWS reInvent coming up in about a month or so. So that kind of covers it for earnings month, or earnings quarter, I guess, if you will. No real kind of surprises. Maybe things were down just a little bit for Q3, and obviously there's always some seasonality in there, but interesting to watch kind of growth rates. And then the last part we're going to cover for Cloud News of the Week before we jump into our interview is 3 acquisitions that happened. Nothing huge, but we always like to kind of keep you informed when there's interesting acquisitions that happen. First was New Relic, who made their name really much in the kind of application monitoring space. One of the early SaaS players has, kind of drifted into observability and so forth, acquired CodeStream. CodeStream's a platform that helps developers do communication along with their code. So trying to sort of drift over from monitoring your applications to being more involved with the collaboration that goes on as you're trying to troubleshoot or see what's going on. Cisco, who kind of dabbles here and there between hardware and software and SaaS applications, acquires Replex GmbH, so a German company. It is sort of focused on sort of the intersection of observability and FinOps. So again, they had made some acquisitions around the application monitoring space as well. This is going to start augmenting that as well. Sort of interesting thing because again, it Cisco continues to be more and more investments in the software space, but not necessarily have an application story. So interesting to see how that portfolio continues to evolve. And then finally, SUSE acquired NuVector. So this really kind of augments their Rancher purchase from a year and a half ago, whenever that closed. NuVector really in the sort of cloud native security, container security space. So we continue to see that space heat up. We've seen a number of acquisitions in that space, and I think there's probably a few more. Not that I have any insight, but the security space around containers continues to be hot as Kubernetes usage continues to grow across all sectors, whether it's across vertical industries or across cloud usage on-prem and in the cloud as well. So lots going on, lots of money. This is always one of the money issues. Anytime we cover earnings, we tend to cover a bunch of acquisitions, and no shortage of those this week. So good to see the industry healthy, lots of acquisitions happening and people moving around. So with that, we're going to jump right into our interview for the week. Kind of a fun show. We talk a lot about applications. We talk a lot about clouds, but we don't often talk about how do we connect those things together. And especially as we start getting into hybrid and multi-cloud worlds, and Kubernetes is involved. And we're going to dig into that with our friends from Juniper right after the break. Today's show is brought to you by CBT Nuggets. You know how much we value ongoing education on the Cloudcast. And CBT Nuggets is exactly what Aaron and I wish we had when we were trying to get our certification early in our careers. CBT Nuggets is all about bringing a personalized touch to learning about cloud computing, virtualization, networking, DevOps, and much, much more. Whether it's their hands-on labs with personalized coaching or the online chat functions that come up with every instructor-led course, CBT Nuggets' team of experts is always there to help you get the most from your training and your path to certification. You can check it all out at cbtnuggets.com/cloudcast and sign up for a free trial. You get access to the full catalog of great training, including virtual labs, quizzes, and other premium features completely free for the first 7 days. That's cbtnuggets.com/cloudcast. And we're back. And, one of the things that we talk about all the time, like we a lot of times we go into topics, we get into depth in topics, we cover things, what we feel like from soup to nuts. And then we feel like every once in a while we go, yeah, that's great, but how does A actually get to B? Or how does that actually work? And one of the things that has been kind of bouncing around my head, and Aaron and I have talked about it a little bit, is we talk a lot about hybrid cloud all the time. Obviously, we're talking about Kubernetes a lot. It's big in the news. Obviously, KubeCon just happened. We talk about hybrid cloud and multi-cloud, and in essence, for the last number of years, the idea that your environment, whether you call it private cloud or public cloud or whatever, is going to be made up of multiple environments, multiple clusters, multiple regions and resources. And we talk a lot about how we build those applications, how we deploy them in an automated fashion and do all sorts of stuff. But we don't always dig into is, how do we connect these things together? How do we deal with domains that are bigger than just, one environment, multiple servers, a cluster, or one cloud? And so we thought, it'd be really good to dig into all that stuff. And who better to go to dig into that than the folks from Juniper? So very, very excited to have Nick Davey, who's Senior Product Manager for Cloud and SDN at Juniper Networks. Nick, great to have you on the show. Looking forward to it.
It's a real pleasure to be here, Brian.
We're going to dig into all that stuff that I mentioned at the beginning. But before we get into that, tell us a little bit about your background. Tell us, what you've been doing. You've been at Juniper for a while, but kind of, how your career's evolved and then really what you're focused on these days.
Yeah, I started out life as a network engineer, working in service providers, both big and small, helping them build metro networks, then mobile networks, and then getting into some peering and cloud architecture. And then I transitioned out of that role into a role at our corporate headquarters supporting our SDN product. And for the past couple of years now, I've been helping service providers along the path of their cloud transformations, and also worked with a number of large cloud providers and platform and infrastructure providers to help them add automation and programmability to their networks and offerings.
Yeah, very cool. Yeah, it's for us. We love finding folks who had lived with technology. They've been hands-on. They've got the scars to prove it, and then they've kind of gone on to building the things and figuring out how to prioritize what we should build and so forth. So excited to have you on. Let's sort of start. I guess maybe we'll take sort of an inside-out approach to this. Let's start somewhat locally. One of the big things that we've seen, especially with Kubernetes, but we've seen it as as containers have evolved, right? We have more and more of what we used to consider infrastructure has become software, whether it's how we represent compute nodes or storage, and especially networking. That leads us to having more overlay networks, software-defined networks, and especially as we get into more and more clusters, so more teams having their own cluster or distributed applications, interconnecting all these things has become more complicated, but there's a whole lot of options out there. So give us some, kind of frame up for us. Give us some context about how you think about, how Juniper thinks about, these SDN networks, these overlay networks, especially in these new, more dynamic environments.
Yeah, so we started our SDN journey back in the bad old days of OpenStack, mainly supporting large infrastructure providers or network service providers modernize their application delivery. And like you said, a lot of the traditional appliances, middle boxes, a lot of the services that we've delivered traditionally using network devices have migrated into software. And we've embedded that software into the infrastructure that we use to build clouds. So the product I support, the Contrail SDN solution, it is an overlay SDN that builds out advanced networks and delivers advanced networking capabilities originally in OpenStack. And as we went along that journey, we found more and more customers who were not only looking at what they could do now with VMs, but looking to the future and seeing how containerization would improve both the efficiency of their application delivery as well as just the overall orchestration experience. And so we've had an eye for a while now how we can bring the kind of robust set of overlay networking tools into Kubernetes. We started off with a CNI that was mainly focused around larger multi-cluster deployments. So basically taking that same problem we solved in OpenStack of how do we distribute a complex set of services around a pretty geographically distributed cloud. And we took a look at what that could do for Kubernetes. And OpenStack gave infrastructure builders an incredible set of tools, but the whole architecture itself was meant to be composable. So you had the ability to create virtual machines, create virtual networks, create load balancers. You could stitch them together any which way you wanted. There were security policies embedded into the orchestrator, but really you were left to your own devices to figure out how all of this stuff got cobbled together to offer up the service that you wanted to host. When we take a look at how that's changed in Kubernetes, Kubernetes has a much more opinionated pattern for how networking and infrastructure should be deployed. It makes it really, really easy to get started. And if you're hosting like enterprise web applications, pretty much everything that Kubernetes has done from a networking and services framework perspective, it sets you up for success. You have the ability to run and scale out workloads really easily using a high-level set of tools, and all of the messy details are kind of handled for you beneath the surface by the CNI, the container network interface. The CNI is the part of Kubernetes that's responsible for implementing all of the networking and service load balancing features. Kubernetes has kind of a framework or an outline for how these services should look and how they should be exposed. But critically, there's no implementation. So there's no built-in set of networking tools that you can consume.
Right.
So, yeah,
well, you hit on two, I think, really important things that people have to remember. And it doesn't matter how long you've been listening to this show. Computing concepts always sort of build on top of each other. So, while some of this may have gotten started in the OpenStack days and people may not have been around when that was going on or what they were doing, there was a whole period of time when we all had to learn, how do you implement these things in software? Because previously they'd been in hardware, or they had been done, in a proprietary way. This is being done in an open way. So, where we are in Kubernetes, builds a lot on where we came from with, from the OpenStack days. And then, like you said, the other thing that people forget a lot about is, Kubernetes doesn't have networking built in, right? Networking is really an added on thing. It has to conform to what Kubernetes does in terms of, being very deterministic and so forth. But, you do sort of have a lot of interesting flexibility about where you can go with it. So yeah, I think you highlight a couple of really interesting things that people have to have in the back of their mind as fundamental building blocks to how we're even getting to where we are today.
Yeah, and you start off with, like, when you deploy your first application on Kubernetes, you start off with just a basic set of networking tools, because really what you want to do is launch that Hello World app and then ultimately get your more complicated multi-tier app up onto the internet.
Right.
You're interested in, are my pods up? Do they have IPs? Do I have an external load balancer? Can I communicate with that external load balancer? Once you pass that point, you declare victory.
Yep.
But as your app grows and scales, as you're left with the operational burden of managing all of these containers and microservices, you start reaching for a more kind of robust set of tools. If the microservices have decomposed a single monolithic application into many, many containers, and it's the network's responsibility now to let all of those modules of an application communicate with each other. Now, for troubleshooting application issues, now the network is involved. I used to manage a Kubernetes hosted application, and it didn't take very long for us to get lost in the game of find the packet. We have calls failing between various modules in the of the application. Microservices aren't communicating properly. What's going on? And so we ended up unraveling long firewall rules and doing packet captures everywhere in both the overlay and the underlay. And we managed to figure it out. But there was no easy way for us to put our finger on exactly like where that packet originated, why it was dropped, and what we need to do to allow that traffic. And that's where the more advanced set of networking tools would have helped us. Like, for example, if I had flow visibility to all of the traffic going on in my cluster, I could have said, that for this particular application or for any application with this set of labels, show me all of the traffic that it's sending out. And I can narrow that focus down and say, show me all of the traffic going to this particular set of destinations. And by having the ability to see all the flows and kind of unravel all the transactions between these two microservices, I would have been able to see that, in my case, in my app, it was a firewall rule that was blocking traffic, or a leaky firewall rule that was not catching all the traffic and sending it into the overlay. It just having flow visibility or having visibility into why your cluster networking is doing a certain thing will save you hours, if not days. And so those are the set of tools that we've been working on. How do we bring visibility into the microservices mesh? How do we bring more analytics? Maybe you don't need to see every flow, but that finding the spike in traffic and correlating that to application behavior changes, that's also incredibly useful. And that's really the same set of tools we use troubleshooting that first generation of cloud infrastructure, as well as figuring out where the packets are going and why a certain behavior is being applied to a certain flow.
Yeah, that was that was always really the thing that intrigued me about Contrail, and having had sort of a networking background early in my career, seeing the things that had to go on in Kubernetes was this kind of understanding that it's one thing to build an overlay that was sort of what I would consider networking centric, right? Like it gave you IP addresses, it talked to DNS, it figured out how to route things and, interact with the firewall and so forth. But then there was the piece of it that was like, you need to have a sense of like how Kubernetes works, because Kubernetes might just get rid of your pod. It might just spin up 4 more, and all of a sudden, like, it's going to talk to a load balancer and say, hey, that's part of a deployment. And, so I think what people don't always understand is like, there's got to be an awareness between the stuff that happens at sort of the traditional layer 2 through 4 or so of networking, and understanding of like things at an orchestration level, because these things don't stay static like they used to back in the old days. They spin up, they spin down. You've got to discover where other components are, and you have to have sort of both elements there in order to not be, like you said, sort of completely blind as to what's going on.
Yeah, in this case, the orchestrator really controls what's going on inside the SDN. So, I've kind of danced around that term a couple times. We've talked about SDN without actually kind of explaining what SDN is doing here. SDN folks probably are either shivering or wondering why we're still talking about it, depending on their experiences from the original, maybe OpenFlow era. So In an orchestrator like Kubernetes, it's the role of the SDN to react to things happening, like you mentioned, like pods getting provisioned, getting destroyed, the scale up and scale down events around a deployment, and populating all the various load balancer entries. The SDN, in essence, is just reacting to everything that's going on inside of the orchestrator and connecting the network to all of the various workloads and updating all the various forwarding entries, and then reacting to that traffic when it comes into our pods or comes in from external networks. So orchestrators are really a great surface for an SDN to plug into, because the whole notion of a cloud is self-service, self-administered compute resources and storage and networking. And so you have the programmatic interface of the SDN to connect to and to implement all of the requirements of the orchestrator. And the administrator or the operator were set up at the high level interfacing with the orchestrator's interfaces and APIs. We're not down, configuring the SDN directly. So that's the sharp contrast between like an orchestrator-based SDN like Contrail and something like a traditional OpenFlow underlay-based SDN. Contrail is really purely focused on implementing the networking inside of Kubernetes or OpenStack in order to let folks build composable, programmable, self-service infrastructure.
Yeah, no, and that's, I think, a lot of this comes back to, the more and more we're starting to build these sort of blended teams, right? So, back in the day, you were distinctly a network admin, you were distinctly a storage admin. Now that we have, DevOps becoming more standardized, more commonplace, I think it's important for folks, whether they live and breathe in some of these technologies, but at least to be aware and to know where to ask questions, like what's possible and so forth. We spent a decent amount of time kind of digging into, what's going on within clusters, right? Like where does networking sort of help us within clusters and across clusters? Let's sort of expand out the scope a little bit. What happens when we start getting into environments that, touch multiple clusters, maybe one application that needs to talk to other services across clusters, or even, I get out of one sort of cloud environment, data center to the cloud. Like what do I need to start thinking about? What happens there that we need to be cognizant about?
Yeah, so especially from Kubernetes perspective, but I mean, we've had this problem for ages as well. Essentially, if you're connecting clusters together, what you're really trying to do is advertise some part of the overlay network in one cluster to the remote cluster. And so ultimately what you need to do is establish connectivity whether that's like underlay connectivity, plugging the two clusters into each other on just a network in your data center, or say like transport to a public cloud, or in the overlay, you have the option to stitch up tunnels between the clusters, and that gives you a more seamless networking experience. Juniper being a traditional networking vendor, we have a very protocol and router-centric view of networking. So networking between sites and data centers, we have a set of tools and protocols for that already. Right. If we are connecting tunnels between clusters, then the actual tunneling doesn't actually matter all that much. We just need to make sure left side speaks the same protocol as right side, and everything is merrily on its way. Yep. When we're interfacing our clusters to that underlay network, we need to speak a set of protocols to advertise all that connectivity. So the protocol that Juniper selected, and really one that we are in love with as a company, is BGP. This is the same protocol that powers the internet core, and wound itself up in the news lately. I'll spare you any jokes, but BGP is really the glue that holds together the internet, and it's also the glue that holds together a lot of large enterprises. We run BGP in our SDN solution to let the clusters advertise routes to other networks, just as if it were a giant distributed router. So when you peer your Contrail-enabled Kubernetes cluster to, say, your data center gateway or firewall or your switches, Contrail will advertise the right set of routes for you to communicate with the cluster workloads. In some cases, like if this is just a bare metal cluster and you're looking to connect it to the internet or some remote sites in your data center, what's going to come out of Contrail is just a set of normal IPv4 or IPv6 routes. Those will get received by your router, and then traffic will start flowing into your cluster. And from your perspective as a Kubernetes cluster administrator, you're going to see just a load balancer type service, an external IP, and then that external IP is what gets advertised by Contrail out to the network. Now, in multi-cluster scenarios where you're hosting a set of applications that needs to communicate with one another, you don't necessarily want to rip off that overlay tunnel because any routes or any connectivity we expose to our data center networks, our underlay switches and routers, they have to store all of that in their routing tables. They need to distribute all of those routes across your WAN or across your data center. Essentially, it creates a lot of state for these networks to manage. Right. So if those networks don't necessarily need to interact with the traffic, you can just tunnel over your infrastructure. And if you are communicating directly between two clusters, all we're doing is, or with Contrail that is, all we're doing is peering the two clusters together. And instead of advertising just plain IPv4 routes, we're advertising tunnel routes. So we're saying to get to this specific external IP address allocated to this load balancer, go through this tunnel. And that means that the data center network or any of the networks interconnecting those two clusters don't need to know anything about the traffic that's going around in the cluster.
Yeah, and I think this is where you start to have these intersections of things that we've known have been proven in the past. So you talk about BGP, and BGP ultimately is the thing that makes the internet scale because in essence, in simplest layman's terms, it allows kind of clusters, if you will, autonomous systems to know about their own stuff, advertise sort of a summary of those things to everybody else. And what that does is it means everybody doesn't have to know everything about everybody else. You just have to sort of know, yes, if I want to go in that direction, I just go to that next thing. And if we think about what's happening, every survey that we see that comes out, whether it's, Datadog's state of containers or, from the CNCF, it's like, one of the things we're seeing, and we've seen this happen before, is sprawl. We're seeing cluster sprawl now in Kubernetes, where every team, every application's got its own cluster. And so, applying something like, really scalable, known networking technology like BGP to that really makes a lot of sense. I mean, it just sort of, you go, look, I know that concept works, and now you have a problem that looks like a previous concept we had. The two of them, sort of fit together naturally.
Yeah, definitely. And this is all towards the goal of making infrastructure easy to administer by its consumer. So we want to get ourselves as far away from the world of firewall tickets and VLAN tickets as possible.
Yep.
Cluster sprawl means that every application or every group within a company is going to have their own cluster. If every cluster is originating a set of applications and they need to communicate to each other, then every time I have a new cluster or every time I have a new service, I potentially need to open a ticket and to speak with my networking or my infrastructure team to allow that service to be advertised into the network, to allow the firewall or to create rules to permit traffic through a firewall. By moving all of that logic up into the overlay, so by connecting all of our clusters together with overlay tunnels, it means that the only traffic that needs to be permitted between all of our Kubernetes clusters is the tunneling traffic, right? I need to permit like our IP and IP or IP over MPLS, whatever the tunneling protocol is, we need to permit that through our infrastructure, but we don't care about the external service IPs. We don't care about the pod IPs. We don't necessarily need to advertise any of that into our infrastructure. It's only when we're actually looking to expose services to the internet or to remote networks for end clients, that's the only traffic we need to advertise out of our clusters.
Yep.
So that's one of the big ways that you can ease the burden of multi-cluster operation is to tie everything together and let the overlay do as much work as possible.
Yeah, makes sense. Let's sort of expand out the scope one more time. So, multi-cluster or many cluster can be an individual company problem, even like within your own data center. what happens when I start getting out beyond the data center where I've got to go across, a lot of people will just say, well, I go across the network or I go across the internet, if you will. There's people in the middle who run those pipes, that maintain those pipes, that make sure they're fast and they're highly available. Like, what do service providers, what are they thinking about these days as they're seeing, more traffic not be sort of just for one company, but it's going, across internet backbones, across environments, VPNs, and so forth. Sometimes interconnecting to the cloud, sometimes interconnecting. Like, what do service providers have to think about? What are their sort of top of mind issues, especially in this context?
So a trend that's emerged over the past couple of years is enterprises have started replacing private connectivity with public internet access. So it used to be that when you needed connectivity between site A and site B, you would procure some kind of private virtual circuit between your service provider. They would connect up your facilities, and then from your perspective as the enterprise administrator, you have a private link between those two sites. What we've learned over the past couple of years is that you can use the internet in a lot of cases as your connectivity between sites. The challenge then is that it's up to the enterprise to establish that private connection over the public network. So this is another case where overlay tunnels and tunneling in general really benefits you. Because once your cross-cluster traffic is wrapped up in an overlay tunnel, again, the infrastructure in between your clusters doesn't need to care about what's going on inside of the cluster. All of that traffic is obscured by the tunnel. So the network in between all of your sites just needs to deliver packets from point A to point Z as quickly as possible and as reliably as possible. But it doesn't need to concern itself with all of the prefixes, all of the services that you're running, all of the pods as they move around. Your network infrastructure just sees the tunnel endpoints, so your actual worker nodes in the cluster. And what that means is your WAN can be simpler. Its job is now just moving packets around between clusters. It doesn't need to carry all of these routes. And because you're maintaining these private virtual circuits, essentially, like that's a pretty fancy name for a VPN tunnel, but because you're maintaining that yourself, it reduces the burden of you having to perform all that configuration and firewalling and all of the other administrative challenges that come with running complex apps and orchestrators. From a service provider perspective, what that means is they need to build really fast, really reliable internet cores, which all of them have been doing for many years now. And it also means that the places we're connecting to are as important as the links we're connecting with. So, for example, as a lot of organizations move their Kubernetes clusters into the cloud, having optimal peering to public clouds is essential. Because that internet infrastructure is essentially your new company or your company's new backbone.
I want to ask you one last question because we've kind of gone all over the place, but the one theme that we've sort of kept consistent in this is, we keep sort of expanding the scope of, we've got these sort of newer applications that are getting built. They're on this more dynamic infrastructure. It's crossing cluster and cloud boundaries. We're also seeing, especially in Kubernetes, things like KubeVirt happen. So, we're able to leverage virtual machines, which people well understand. And then we're seeing things like, Kubernetes and KubeVirt being used out at the edge. Again, as we sort of keep expanding the scope of, how do we get to these new places where we're deploying applications? Are there unique things we'll have to think about networking to the edge that the Juniper's thinking about, or from a scale perspective, what are some of the things that you're sort of top of mind in terms of what this edge means and where it's going to potentially change some things?
Yeah, the edge is another remote cluster. So if you've solved that multi-cluster networking problem very well, edge sites present just another remote cluster challenge for you to tackle. Edge sites, depending on how you're deploying them, in again, legacy OpenStack days, not to focus too much on the past, but it provides a good pattern moving forward. In legacy OpenStack days, we had a remote compute architecture where we could have just pure compute deployments at sites. and then treat those smaller sites as an extension of a bigger cluster. And the reason for that was to minimize the control plane footprint at those remote edge sites. So you don't want to have, an OpenStack controller, an SDN controller, and then a whole bunch of computes when you're trying to fit all of this into a broom cupboard or wherever your edge site is.
Right.
With Kubernetes, that changes a little bit. The control plane is obviously much lighter, much more efficient. And so it's not necessarily a bad thing to put a Kubernetes control plane at your edge site, but that means, again, you're solving a big multi-cluster problem there. As we start moving towards truly resource constrained, as we start moving towards more resource constrained edge sites, so think like 1 or 2 computes,
right.
We're going to get back to that remote worker node problem. And again, not to have the same solution to every problem, but again, that's where the overlay really saves the day. For those remote sites to communicate back with anything else in the cluster, whether the remote site is a dedicated Kubernetes cluster or just a worker node at the end of a really long wire, the overlay makes the application networking work the same as if all of the nodes were under one roof. There's one minor exception to this, because your overlay traffic, of course, by definition, it stays inside of the tunnel. It doesn't interface with the rest of your network. Edge sites, especially for service providers or content providers or anyone else looking to offer up services to external networks at their edge, you're going to have some sort of gateway or ingress, basically an entry point into your cluster where you're going to offer up services from. So in these remote compute architectures that we've deployed with Contrail, we have the ability to pick kind of where your egress is on a per remote site basis. So you can say, for example, this particular broom cupboard uses this firewall that's located at this IP address. And, the rest of your compute, your centralized data center is going to use these big set of data center routers. And that's where services are going to be exposed from the central site. And you can use that to offer, say, low latency services right at your edge, while still selectively leveraging the overlay to get traffic back to that central DC whenever you need to use resources that are inside the cluster.
Yeah, so it's the funny thing about networking is, once you learn some fundamentals, the environments change, but you're able to, if you do it right, you use the right tools, you're able to reuse them in a number of places. And it's good to hear that, as edge sites grow, and they'll probably be 10x or 100x, the number of clusters you have in your data center, you don't have to completely learn everything brand new. There's a lot of things that can be reused, relearned, kind of repurposed and reused and so forth, and will help us, especially as Kubernetes becomes more mainstream. We see more and more companies using it, and wanting to take advantage of the sort of the deterministic nature of what it does, and helps build applications. Nick, we've covered a ton of stuff. We started in a cluster, we got into multi-cluster, we got in cross cloud, we got into edge. We sort of covered a lot of everything. Last thing I'll sort of throw out, if folks want to pick your brain, want to learn more about kind of how Juniper's helping scale this, make it simple, what are some of the good ways to do that, and maybe how do people pick your brain or ask you questions?
We have a bunch of white papers published on juniper.net that we'll include in the show notes, where you can learn a little bit more about how Contrail and SDN are solving problems in both centralized and distributed Kubernetes deployments. There's also an open source community that we support. Contrail is based on the upstream Tungsten Fabric project from the Linux Foundation. Mm-hmm. So if you want to get your hands dirty or dive into some of these more complex networking problems that you can solve with SDN, you can join our community meetings. The website is tungsten.io, and there's a community calendar. We meet on Thursdays and Tuesdays. We meet on Tuesdays and Thursdays, and you can feel free to dive into our Slack or our mailing lists, join the meetings, and ask questions.
Nice. Yeah, no, it's always good, that we have not only the technology being open, but the communities being open as well. So very, very cool. Well, listen, Nick, I want to thank you for all the time today. I know we dove into a lot. I sort of put a lot on you in terms of bouncing all over the place, but I appreciate you, again, kind of helping us connect the dots of, we want our applications everywhere. We want connectivity everywhere. And sometimes we sort of forget or don't know how the sausage gets made or how the bits get routed around. So I appreciate you filling us in, giving us some details. Folks, on behalf of Aaron and I, we want to thank Nick for his time today. We want to thank all of you for listening, for telling a friend, for helping us grow the show and giving us feedback in all the ways that you listen to your podcast. So with that, I'm going to wrap it up and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.